numbers on a paper.
Have you guys ever been given some series by your professor that you should test if that series converge or diverge? And after applying so many series techniques that you know, it seems abortive? Worry no more, guys, because in this video today we shall be looking at a qualitative study of the integral test. So guys, throughout this video I shall be explaining to you guys every bit, every concept involved in the integral test. Before then, guys, let's introduce ourselves. I am Umenju Macarius, and guys, this is Humble Mark Academy, where I take complex science concepts, those ones that my students find it very difficult to understand. I break them down into tiny pieces such that any student across the globe can use his or her understanding now to score a better mark in his or her exams. In exchange, guys, all I want you to do is to hit that subscribe button looking at you, because I can only help you so well to pass your exams with good grades once you've subscribed to my channel. And friends, please give the video a thumbs up. That goes a long way to motivate me to keep creating more great content for you guys. Please share the video as well with your friends. That way they are going to have access to great contents like this. Great. Let's get started, guys. Great, guys. All right. So guys, if we suppose that we have some series, let's call it the series as n goes from k to infinitive of an. Guys, the reason why my series has started from k here is because k is any number, because the starting value of a series does not really matter. Okay, it does not really matter so long as it is in the domain, it is within the domain of the function made from that series. Great. So guys, if we have a series that is from n goes, that's when n goes to k to infinity of an, guys. If we let our f of x equal to a of x, that therefore implies, guys, for the integral test is simply telling us that if we can get the definite integral going from k to infinitive of f of x dx, so long as this gives us some value, we can call that a. Now, guys, let's lay some conditions on this our value of a. If a is a finite number, then, guys, the series as n goes from k to infinity of a, and guys, simply converges. And guys, if a is an infinite number, then the series as n goes from k to infinity of an diverges. Great. So guys, in summary, once we have integrated this guy from k to infinity once we've integrated f of x from k to infinity, guys, and we get some value a, if a is a number, therefore the series converges. If a is infinite, namely, guys, infinitive, it means the series diverges, means the integral has diverged. Likewise, the series also must diverge. Great. So guys, let's lay some conditions under which we can use the integral test, because the integral test, we cannot use the integral test for all series. Okay, we cannot. There are some conditions that must be met before the integral test is valid. So guys, in the very first place, right, an must, that is in this interval, from the interval from k to infinitive, an must be, in the first case, it must be positive. That is the second case, guys, it must be continuous, and the last case, it must be what? Decreasing. There are some textbooks that instead of continuous, they will tell you differentiable, but let's keep that for now. Okay, let's keep that for now. It should be continuous. Get it? Great. So guys, once these three conditions have been met, guys, we are done to use the integral test. If one condition fails, you cannot use the integral test. Great. All right. So guys, let's take an example. Let's test whether or not the series below converge, which the series as n goes from 2 to infinity of 2 over n squared minus 1. Great. All right. So guys, we are going to define some function. We can call that f of x equal to, we have 2 over x squared minus 1, as what we did here, right? That f of x equal to a of x. That is, anywhere we have n, we simply replace the word x. Great. So we have it. That therefore implies, guys, if we can look for the definite integral going from 2 to infinity of 2 over x squared minus 1 dx, all we seek to get is some value, right? Great. So guys, the best way I think for us to integrate this guy is by expressing the bottom in partial fractions, as we don't want to get ourselves involved with hyperbolic functions, right? because we can simply integrate this one as -2 times the hyperbolic tan inverse of x. But like I said, guys, let's not go into hyperbolic functions. Let's just do the normal terminology we know. All right, so guys, we are going to factor out the bottom. By so doing, we are going to have the integral from 2 to infinity of 2 over factoring out the bottom gives us x minus 1 into x plus 1. Great. The best way for us to proceed at this point now is to express the bottom in partial fractions. By so doing, guys, we are therefore going to have the integral of from 2 to infinity of 1 over x minus 1 over x plus 1. Great. So guys, at this point in time, if we integrate term-wise, we are simply going to have, and keep in mind that the denominators are all linear factors with the derivatives both equal to 1. So we are therefore going to have the natural log of x minus 1 minus the natural log of x plus 1. Keep in mind that on normal occasions, I am supposed to put absolute value signs in this natural logarithm, but since since it is positive in the interval from 2 to positive infinity, guys, I don't need absolute values. Limits of integrations, guys, will be going from 2 ending at positive infinity. Great. So guys, if we simplify this natural log functions so well, since you know the natural log of a difference is simply the quotients of their interior still in the natural logarithm, and the limit from as x goes to infinity, guys, of such a function, guys, and the upper bound, simply thus inserting the upper bound into this our primitive is like taking the limit when x goes to infinity. So we are going to have the limit as x goes to infinity of this our function part, that is when we combine it together. While we combine it together, we are going to have this. Then when we substitute 2, right, if we put in 2 into this guy, we are going to have 2 minus 1, which gives us 1. Natural log of 1, we have natural log of 1 now. Then we have minus the natural log of, when we substitute 2, we are definitely going to have the natural log of when we put 2 into this guy, right, we are going to have natural log of 3, that is minus natural log of 3, but since the upper limit minus lower limit, we are going to have positive. Likewise, natural log of 1 is 0. So we do that so well, and this limit, guys, simply gives us the natural log of 1 since x is going towards infinity, and the degree and the coefficients of x in the top and bottom of this our fraction is the same. So we have natural log of 1, then natural log of 3. Natural log of 1, guys, as all know, is what? 0. So we are going to have the natural log of 3 as our answer. So guys, you can say natural log of 3 is a finite value, right? According to what we have here, that we let f of x equal to some function a of x. Then if we get the integral from k to infinity of that function, if it gives us a, if a is finite, then the series converges. So we can come back and say that hence the series as n goes from 2 to infinity of 2 over n squared minus 1 is simply converges. Great. That's a very important conclusion, guys. It simply converges by the integral test. You must have to mention the test, guys. You must convert by the integral test. All right. So guys, that's it. If you didn't understand, guys, please leave your worries in the comment section below. I'll get back to you as soon as possible. All right. So guys, let's have this important note that if we have the series as n goes from 2 to infinity of no longer n squared minus 1 now, but 1 minus n squared, we cannot use the integral test. Why? Let's verify if these three properties hold or not. Let's look at positive. Is it positive? Guys, is this our series positive in the interval from 2 to infinity? Of course not, right? Because the sequence of this our series, that's the function part, is simply the negative of this our series, right? I will know this series is a positive series, so being a negative means all the terms of this our series are negative. So this condition has failed, right? Great. Let's look at continuity. Is it continuous in the interval from 2 to infinity? Great, guys. This condition is true, right? Good. All right. Let's now look at decreasing. Is it decreasing? Wrong, guys. It is not decreasing, right? Since we have a series of this form, that we have this our series which is decreasing, right? So if we take the negative of it now, which is going to give us this series, it will not be decreasing. It will rather be increasing. All right. So guys, in essence, what I'm trying to say is that if one condition fails, no need to test the rest, because even if one at least even if at most even guys one condition fails, you cannot use the integral test anymore. Great. So guys, that's it for the integral test, guys. Please, if you found the video useful, guys, do endeavor to give it a thumbs up before you go, guys, because it motivates me to keep producing more great contents. Guys, keep on coming to our channel. We have important concepts for you guys to learn. Thank you so much, guys, and have a blessed day.